All right, welcome to the second semester of Math 3. We're starting off with section 6.1, Simplifying Radical Expressions. All you're going to need for these notes, there's nothing to print out. It's just a blank sheet of paper. There's not much writing to do, which is why I didn't print anything out for this set of notes. So if you don't have a piece of paper, pause the video, go grab one real quick, and we'll get started. And before we start with the new stuff, because there's only really one new idea, we're going to do a little bit of a review of radicals. Okay, so we'll just put at the top here 6.1 notes. And like I said, there's not going to be a whole lot of writing to do. Okay, so again, we're simplifying radical expressions. Okay, so a radical expression is something that has a radical in it. In other words, a square root symbol. Okay, so just real basic stuff for a quick warm up, and then we'll get on to the new stuff. If I have something like the square root of 9, okay, well, what is the answer to that question? Now, hopefully you're all thinking 3. Okay, and then right, the answer is 3. Then how do we get the answer of 3? Okay, well, one way to get our answer when we're simplifying a radical, if it's a square root, that means I'm looking for 2 of something. If it's a cube root, I'm looking for 3 of something. If it's a fourth root, we're looking for 4 of something, and so on. A square root means the second root, the square root. So we want to see, are there any pairs of numbers that multiply to give us that number? Okay, because again, this symbol is asking us what number times itself equals that thing. So then we would say, okay, well, 3 times 3 equals 9. And then since I have a pair of 3's, anytime we have a pair of something, we can pull one out. So then our answer would be 3. Okay, so then is that correct? Sure. But think about it. Is 3 the only thing that multiplies to give us 9? Is 3 times 3, I should say, the only number times itself that multiplies to give us 9? Well, no. Negative 3 would also work, right? So when I said, what's the square root of 9, and you said 3, was that wrong? No. This is called the principal root. Okay, so if your equation, if your problem looks just like this, where it's just the square root of something, let me show you something from the homework. So for example, number 7 from worksheet 1, what's the square root of 36? Well, 6, and sure, that's the answer. We call that the principal root. Okay, now when do they want the positive and negative version of your answer? Okay, well, if they had something like this, instead of just the square root of 9, what if they had, let's say, x squared equals 9? Okay. All right, so if we have x squared equals 9, well, how do we solve that equation? Well, here we want to take the square root of both sides, and then the square root of x squared, we get x equals the square root of 9. Well, that could be positive or negative 3. Okay, so when do we want just the principal root, which is the positive answer? Well, if there's no equal sign. So our equation was just this. It's not really an equation, it's just a statement. Our problem was just that. If there's an equal sign, then that's when we want the positive and negative answer. Okay, so real quick, something like, oh, sorry, I turned the page here. Worksheet 1, number 7. That would just be 6. There's no equal sign. They just want the principal root. They just want the positive answer. If we look at something like number 34, well, what squared equals 16? Well, since there's an equal sign, then that's when we want the positive and negative answer. So 4 squared would equal 16, or negative 4 squared would equal 16. Okay, so hopefully you learned that last year. That's just a little refresher. Let's go ahead and move on to the new stuff here. We don't want to spend too much time on stuff we've already learned. Okay, let me fix the zoom a little bit. There we go. Okay, so this is just refresher stuff, and then now we're going to get to the new stuff. And again, the new stuff, we're mainly looking at one idea, which we're going to look at a bunch of examples, and then hopefully you start to notice a pattern and figure it out for yourself. Okay, so I'm not going to tell you the rule right away. We're going to just look at some examples and figure something out here. All right, let's get started. So our first example, if we have the square root of x squared, well, what is the answer to that? Okay, well, kind of like we saw over here, the square root of x squared would just be x, right? Because I can think of this as x times x. So then, yeah, x multiplies to give us, sorry, x times itself multiplies to give us x squared. So is the answer just x? Well, no, it's actually the absolute value of x if we want to get technical. Okay, so why is it the absolute value of x? Well, here's why. Can x be a negative number here? Well, sure, because once I square that negative number, it's going to be positive, and then I'd be taking the square root of a positive number, which is fine. Okay, but if x is a negative number, that means my answer would come out a negative number, which we can't have that. We can't take the square root of something and get a negative number for an answer. That's why we need the absolute value bars. Okay, so sometimes we're going to need the absolute value bars, sometimes we're not going to, and we're going to discover when we're going to need them and when we're not. Okay, So anyways, there's the answer to that first question. Let's look at another one. How about the square root of x to the third power? Okay, well then what's my answer going to be here? We'll see, if I factor this, I can get x times x times x. So I would have a pair, so I can take out an x, and I'd have one left over inside the radical. So then that's my answer. Do I need any absolute value bars here? No, and here's why. And this is kind of the confusing part. Can x be a negative number here? Well, no, it can't, because what's a negative number raised to the third power? Like negative 2 times negative 2 times negative 2. Well, that'd be negative 8. Can we take the square root of negative 8? Well, no, we can't take the square root of a negative number. So since x can't be negative, because if it was, we'd be taking the square root of a negative, which is not okay. So since x can't be negative, we have to assume that it's positive. Well, if x is positive, then that's positive, which is fine, and that's positive, which is fine, because then we're taking the square root of a positive number. Okay, so again, that one's a little funky, but since x can't be negative, otherwise this just wouldn't work, we have to assume it's positive, which means that's positive and that's positive, which is fine. So we don't need any absolute value bars. All right, let's try another one. How about the square root of x to the fourth power? Okay, what's the square root of x to the fourth power? Well, here I can get two pairs of x's, so I can take out two x's, which is x squared. Do I need any absolute value bars? Well, let's see. Can x be a negative number here? Well, sure, because when I raise that negative number to the fourth power, it would be a positive number. So yeah, I can take the square root of a positive number. But can my answer be negative? Well, would that make a difference? Well, no, because if x is negative, what happens when I square it? It becomes positive. Okay, great. We don't need absolute value bars because it's never going to end up being negative in a spot where we don't want it to be. Okay, because remember, we can't take the square root of a negative, and if I'm taking the square root of something, my answer can't be negative. But neither of those things are going to happen because I got these even powers here. So that one's good. We're done. Okay. How about x to the fifth power? So with the square root of x to the fifth, what's that one going to be? Okay, let's see. Just like up here, if I had, with those 4 x's, with 4 of these 5 x's, I can make 2 groups of 2, so I can take out x squared. And then we would have an x left over. Okay, do I need any absolute value bars? Well, let's see. Can x be negative here? No, because if it was, we'd be taking the square root of a negative. Okay, so then we have to assume that our x's are positive. And if x is positive, well, that's going to be positive, especially when I square it. And then that's positive, so we're good. We don't need any absolute value bars. Okay, all right, let's keep going with this. What about the square root of x to the sixth power? What's that going to equal? Well, let's see, if I have 6 x's, I can make 3 groups of 2, so then I can take out 3 x's, which is x to the third. Okay, let's see, do I need any absolute value bars here? Well, can x be a negative number here? Sure, because when I raise it to the 6th power, it's going to be a positive number, and yeah, I can take the square root of that positive number. But if x is negative, well, what happens over here? If x is negative, a negative number to the 3rd power is going to be negative. That's not okay. I can't take the square root of something and get a negative answer. So then that's when we want absolute value bars. Okay, now hopefully you're starting to notice a pattern here. Let's do a few more and see if you can figure out that pattern, and then we'll write the rule for this thing. But let's keep going with this. All right, next one, the square root of, you guessed it, x to the 7th. What is the square root of x to the 7th? Well, I can make 3 groups of 2, so I can take out x to the 3rd with 1x left over. Okay, do I need any absolute value bars? Let's see, can x be negative here? No, because if it was, I'd be taking the square root of a negative. So I have to assume this is positive, which means that's positive and that's positive, so we're good. Okay. So again, that one's kind of silly because we have to assume it's positive. That's where it can get a little confusing. Okay. But that's the answer. All right, next one. Almost done here. A couple more. How about the square root of x to the 8th? What's my answer? X to the 4th, because I can make 4 groups of 2 if I have 8 x's. And then do we need any absolute value bars? Well, let's see. Can x be negative? Sure, because if I raise a negative number to the 8th power, it would be positive. And then if x is negative, is that a problem for my answer? Well, no, because if x is negative and then I raise that number to the 4th power, it's going to be positive. So my answer would be positive no matter what, whether it's positive or negative for x. So I don't need absolute value bars because it's going to end up positive no matter what. Okay. All All right, two more, then we'll write the rule. Hopefully you're figuring out the pattern here. How about the square root of x to the 9th power? Okay, if I have 9 x's, I can make 4 groups of 2, so I get x to the 4th with 1 left over. Okay, do I need any absolute value bars here? No, why not? Well, can x be a negative number? No, because then I'd be taking the square root of a negative. Okay, well then we have to assume x is positive, which means that's positive and it's all good. Okay, all right, last one, then we'll write the rule. How about the square root of x to the 10th power? So what's the square root of x to the 10th power? Well, if I have 10 x's, I can make 5 groups of 2, so x to the 5th power. Do I need absolute value bars here? Well, let's see. Can x be negative here? Yes, because when I raise that negative number to the 10th power, it's going to be positive, so that's fine. I can take the square root of that positive number. But if x is negative, what's a negative number raised to the 5th power? Well, that would be negative, right? I can't take the square root of something and get a negative answer, so then that's when we want the absolute value bars around the answer there. Okay? All right, so in general, when do we need absolute value bars? So we're just going to literally write those words in general. If we're taking, now it doesn't just have to be the square root. I should have maybe written this a little bit bigger. But if we're taking any even root, so it can be the square root, which is the second root, or the 4th root, or the 6th root, or anything like that. Let me adjust the camera a little bit. But if it's any even root, and we have something, doesn't have to be x, but anything else, x, y, or stickman, or whatever your variable is, raised to any even power, and my answer comes out something raised to an odd power. Okay, so again, if I'm taking the square root of something raised to an even power, and my answer is that thing to an odd power, well then that implies that we need the absolute value bars around it. So our answer is going to be x raised to that odd power with absolute value bars. So again, even, odd, that's when we need absolute value bars. Okay, most of the problems we do are going to be square roots, but you'll see a few that are 4th roots, maybe even some 6th roots. We won't really go much higher than that, but again, any even number here, and any even number here, and any odd number here, that's going to mean we're going to need the absolute value bars. Okay, so like I said, the rest of worksheet 1 is pretty much stuff from Math 2. There are a few tricky problems that we'll go over together in class, but you should be able to handle most of that worksheet with what you learned last year. Make sure if you have any questions, ask me in class.